Man, I've really been struggling this year. Physics is so hard. If only I could think like the great scientists who discovered them.
Let me grant you your wish, my son. Alakazam!
So you can't understand the most elementary of my work.
Well, it's not my problem that your elementary work is so hard to understand.
Yes, it's me, Sir Isaac Newton, the greatest mind to roam the earth. My greatest achievements were during the plague, but your words are like buboes. They hurt. No, they don't. You're like Leibniz. You can hardly think for yourself. But I'll lecture you, cause I'm noble, and in your classes you'll excel. The 3 laws of motion. A wonderful place to start. Start with the second one, the most important one, the formula to memorize by heart. An object's change of speed over time is called acceleration. Calculated by the final velocity minus the initial one divided by t. The time elapsed between the change of speed and mass, measured in kilograms, is self-explanatory.
But what is velocity?
Velocity is speed, combined with which way you're headed. If rightward is positive, moving left would be negative, and is measured in meters per second, distance over time, and that is another formula that you should keep in mind. Now, where were we? Yes, multiply these two together. A force is what you get, measured in newtons, a push or a pull coming from interactions between objects.
Okay, I get it. The equation shows that you need more force to accelerate a heavier object to a certain speed than a lighter one, which makes sense.
Correct.
And since velocity can be negative, acceleration can be negative, so forces can oppose each other.
When you add forces with differing signs, yes.
But what about the other 2 laws?
Right, the first law concerns inertia. An object will not accelerate unless it is acted upon by an unbalanced force. If I were a horse, my position won't change till I gallop my course by pushing the ground. Or say there's a cart that's standing still. It will only move if we overcome gravity and push it uphill.
But what if the cart is moving?
Say it rolls at a constant speed. The first law still applies. To change its speed, a force it needs. In either of these cases, the objects are at equilibrium, refusing to change their velocity until a force is applied on them.
Okay, so the first law states that an object's speed won't change unless it's experiencing a force.
Yes, you're finally catching on. Now let's wrap up with the 3rd law.
It's really simple if you think about it. My weight pushes on this table, as I said. The table supports me by pushing me up, which displays that forces are always paired up. An equal opposite reaction. Take a swimmer pushing off a pier. She pushes the board opposite of the direction that she jumps off through the air. The pier exerts on her feet a force, a response to the push by the human. I hope you understand these laws to demonstrate physics like human.
Okay, I think I understand all the 3 theories that you made. So basically what you're saying is the 3rd theory is sort of like karma.
Huh?
Every action has an equal and opposite reaction, just like karma.
Right, sure, whatever help you sleep at night. Look, I've got some important work to do. There's a lot of responsibilities behind being the mind behind all of physics kind.
Now I won't stand for that, Isaac.
Now what do you mean you won't stand for that?
I won't let you take credit for all of physics. After all, you were wrong on many things.
Why should I listen to you? I don't even know who you are.
You will.
Would you be surprised if I said light was a wave and wiped all of your discoveries about light away? Well, I'm about to astonish you, and teach you too. You'll hear about waves from the dude who made them cool. First, what is a wave? It's a disturbance, you see, that travels through a medium to transport energy. It's like an ocean tide, or a rope you can swing. But for clarification, just know one thing, they don't transport matter. The rope doesn't go, it just bobs up and down unless the energy flow. Any point on the rope moves up and down, but not left and right. Now that we have that down, in any given wave, there's peaks, nodes, and troughs. The highest point, middle point, and lowest of them all. From peak to peak, or trough to trough, we find a distance called the wavelength, lambda. It's the distance the wave takes to go through a full cycle. And speaking of cycles, there's another thing to know. Frequency denoted F is the number of cycles a wave goes through in a second. So, with these two, you can find the speed of a wave. As you mentioned, velocity equals distance over time. Lambda is distance per cycle, F is cycles per second. Multiply them together, distance over time.
V equals lambda times F.
That's correct.
Are there other types of waves I should be worried about?
Well, we discussed transverse waves in particular. The wave travels right, but it falls perpendicular.
The other type of wave is called longitudinal, which is a wave that behaves like a spring. Energy still travels a certain direction, say horizontally, but the medium that it disturbs oscillates in the same direction rather than a perpendicular direction, like the transverse wave.
I've had enough of your nonsense. None of this could possibly be the way that light works.
How can you be so sure?
I work with light more than you could dream of doing. I discovered that white light is made of all the colors. I discovered that objects get their colors from the light they reflect versus what they absorb. And most importantly of all, I believe that light is made of particles, corpuscles.
Wrong again, Isaac.
I'm famous for my double slit experiment, shining sunlight through a window and then through little slits and then measuring its intensity as it made bands on the wall, with light and dark fringes spaced evenly across. Now this can only happen if light is a wave, because of two key manners in which waves behave. The first is interference, quite simple indeed. To explain it to you, let's go back to our string. If you have two pulses traveling towards each other, when they hit, they'll combine into just one pulse, whose height, called the amplitude, will have the same magnitude as if you combine the heights of the beginning ones. So if two peaks moving on a string collide, they'll overlap and form one pulse sky high, and if a peak and a trough decide to coincide, they'll flatten out and their heights will become nullified. In the context of my experiment, the light and dark fringes are results of interference. At the bright bands, troughs overlap, as do peaks, and peaks and troughs cross paths when the brightness is weak.
But that doesn't disprove my particle theory. All I see is summation a toddler could do easily.
Isaac, I knew you'd fall into my trap, cause there's one more thing waves do. They diffract, which means they bend around an obstacle or a slit, only when their wavelength, lambda, is close enough to the size of the slit or obstacle, within one order of magnitude. Now, in my experiment, what I found to be true was that the light spread far from the slits it passed through. Instead of making two bands like a particle would do, it diffracted and made fringes. Your move, fool.
I see, your work makes sense. Regardless, you wouldn't have been famous if it hadn't been for Optics, the book that I published, the work that you lavished, the book of particle theory that made me father of science.
It seems like my mind alone is not able to overcome the force of Newton's. But, lucky for me,
Oh look, more rascals I have never heard of. What have you got to offer?
Je m'appelle Charles-Augustin de Coulomb, about to revolutionize an Englishman's way of thought, take Newton off his throne like the apple that dropped, and led him to gravity. But I've got a lot to inform you of, Newton, close-minded Pluton. Earth's not Newton-centric. Who would have thought?
You overthrowing me? That's a long shot. Should have never mentioned planets. Gravity's my jackpot. The law of universal gravitation, an equation that provides the force of gravity at whatever location. Gravity is a pull, a force of attraction between objects that is caused by their masses. G is a constant, a very small constant. The m's are the masses of the attracting objects, and r is the distance between them, not a radius. It has a greater impact on the force than a mass does. Mass can't be negative, and neither can distance, so gravity's force is always positive. Makes sense, always attracting, pulling you down. That's why you'd never fly away from the ground.
Oh, Mr. Isaac, I have a question. What's G's value?
Read the boards by suggestion.
10 to the negative 11th? That's funny. It proves that gravity is weak, you dummy. See Coulomb's law? Yes, named after me. Describe attraction that comes from electricity. In any given object, there's protons and electrons, small charged particles that make up an atom. The proton has a small positive charge, and it never leaves the atom. Its counterpart, the electron, has a small negative charge, the only particle transferred between atoms. If there's an imbalance in the amount of these two, the object has a charge, denoted by Q. It always seeks to get its uncharged state back, thus attracting the particles that it lacks. So an object that is positively charged attracts negatives and pushes positives far. My law states the strength of electrical force depends on just how charged the two objects are. An object's charge depends on the variation in the amount of its electrons and protons. Each has a charge of this many coulombs. To find the total charge an object carries along, of the two, find which particle there is more of. Then find how many more of them there are than their counterpart. Multiply that by this charge per particle. It's positive if you use protons and vice versa. I found my law with a torsion balance tool, a pendulum with charges on the ends of a spool. Rotation resulting from electric forces allow me to derive this useful relationship. My law is quite similar to that of gravitation. A constant, two quantities, the square of their distance. The charges can be small, but there's one key difference. It lies in K. Coulomb's constant, 9 times 10 to the 9th, trumps the so-called big G by at least some 20 powers of 10. While Q's may be small, it's staggeringly obvious. Electric force is much stronger than gravity is. Excuse me, I can't wait all Faraday. If I can overcome poverty and be my own teacher, it's easy to tease this mouth-breathing Ebenezer. I'm a faithful man, praise the Lord through and through. So Isaac, you're about to get Sunday school. In addition to charged particles that stand still, charges can flow through a wire as well. The charge that flows through a given point per second is known as the current, measured in amperes. These charges are actually moving electrons, passed through a wire by metallic atoms. They enter their orbits, then exit them quickly, thus resulting in electricity. Current is useful and also quite interesting. You can use the flow to power things with electricity, light bulbs, motors, heating, and more. These are examples of resistors. Resistors slow down the current in a circuit. They use the electrons to power their mechanics. The level of slowing is measured in ohms. With more ohms, the more electrons are slowed. Now let me discuss one last thing. It'll seem like magic, but is really real indeed. If you put a wire in an area that's magnetic, inside of the wire, you'll generate a current. But first of all, what is a magnet? Aside from the horseshoe I'm sure you have already witnessed, a magnetized object has a north and south pole. They always come together, they're inseparable. North will be attracted to south and vice versa, and you can draw arrows to make this point clearer. They point in the direction a north pole would go, away from north and toward the south pole. In induction, wires start to be magnetized, but the wire wants to stay unpolarized. To stay in its ground state, a current is induced, just enough until the poles are completely reduced. As the wire enters, the current's counterclockwise, and exits, it changes to clockwise. This current generated works to counteract magnetism building up inside the wire. Hey Isaac, we're both men of many different talents. I studied philosophy, medicine, and logic, but in terms of collaboration, I was an enjoyer. I combined minds with a refined Leonard Euler. And listen, I know what it's like to be stolen from. My father copied one of my papers after I published them, but your pride here is absolutely inexcusable. So prepare, sir, as I burn you like a crucible. When it comes to fluids, I'm the alpha dog. I earned that position through developing my law, a principle applying to gases and liquids that move without being slowed down by friction. First let's talk pressure, what I'm putting Isaac under. In fluids, molecules move and hit one another. When inside containers, they also hit the borders. Pressure comes from how hard and how many times this occurs. Say there is a fluid moving slowly in a tube, exerting pressure on the walls as it travels through. If we speed up the fluid so that it travels quickly, the pressure it exerts will experience a decrease. That there's Bernoulli's principle. Inversely relating speed and pressure, the mind of yours truly is invincible. And furthermore, I've got an equation to come with it. Look to the board, the variables, I'll explain them. The big P is pressure exerted on the walls. The small p is the liquid's mass over its volume. The v represents velocity at which it moves, and these always sum to the same value. If this is the case, say the liquid speeds up. This term here becomes greater, so pressure must decrease to yield the same constant, thus demonstrating my principle in action.
This form of my equation is for a liquid that flows at a constant depth. In other words, through a horizontal tube. It's not complete, but I just use it to prove my principle.
Well, if you're not even going to show the full equation, shut your mouth for 1 second. I'm a passionate sailor and I've got a yacht waiting for me.
I'm William Thompson, later known as Kelvin, earned the name Lord planting cables through the ocean. Aside from writing scientific papers at 16, I also revolutionized their theories about heat. Heat is a property of any given object, due to, as Bernoulli mentioned, molecules' movement. The hotter an object, the faster they move, and the more heat energy the substance can use. Heat is a type of transferable energy. It can be shared between objects that are touching. If a hotter object touches a cooler one, they'll both end up at an equal temperature. The hot object will lose heat and cool down, and the cold object will absorb the heat lost. This summarizes the second law of thermodynamics. Heat always flows to cold from the hot. Now, another way to describe the second law is that the entropy of a closed system never drops. Entropy is the level of disorder in a system, the amount of ways its heat energy can be distributed. This is what I proved during life as a scientist, that after a transfer of heat between objects, the total amount of entropy between them always increases with
without exception. Now, individual objects can become more orderly, such as liquid water turning to ice through freezing, but the energy needed to make the water cool produces more entropy than the freezing removes. There's another law that proposes a situation where molecules in a substance sees movement. Its point of no movement is called absolute zero. On the Kelvin temperature scale, the point most low. The Kelvin scale deals with how fast particles are moving, always 273 more than Celsius readings. At that point, entropy and heat equals zero. Impossible in real life, but the baseline for thermo.
Now that you know what other minds have done for your work,
How we've used it as the building blocks for innovation.
and how we've shared the same struggles as you have.
Maybe you'll treat your successors with a little more respect.
Oh yeah? Well, your beard is...
Majestic, I know.
There's got to be something horrendously inferior about each and every one of you.
This dude, man. I swear to God, man. This dude. Huh?
Are you laughing at these fools disgracing my legacy?
No, I actually love this. This is way better than any worksheet or whatever we do in class. I mean, I actually wouldn't know because I don't go to class anymore, senioritis.
Oh, marvelous. What have you two done to my work? What are you even wearing?
Well, considering how you've treated others who've built off your work, you'll be quite satisfied with what we have done.
And believe us, we know what we are doing with our fashion sense.
We're going to break you down to a subatomic level. Burn this plague arrow rat, leave him even more disheveled. We're the fathers of quantum physics, it's made for big brains, dealing with particles millions of times smaller than sand grains. Newtonian mechanics sucks when it comes to small things. It assumes that you can divide energy infinitely. But by studying radiation coming from space, I developed a theory that took classical mechanics' place. I discovered that when it comes to light, you can't divide its energy an infinite amount of times. At some point, there is an amount, a packet, that cannot be divided any smaller, a unit. A beam of light is made up of what we call photons, units of light, in other words, light's quantum. The smallest possible amount of light that moves awry, but they're not exactly particles, they're quite wave-like. Planck's constant, denoted by h, the minimum amount of energy a photon can possess. Since photons act like waves, they have frequencies, and using h alongside that gives energy. E equals h times f. Every amount of energy is a multiple of my constant. Though your mechanics divide energy without limit, it's clear you haven't quite modernized your rhetoric. It's time for me to drop bars like atomic bombs. I'll tell you where these photons Planck mentions comes from. As Coulomb said, there exist electrons, highly mobile particles within an atom. They orbit the nucleus at different separations. They also gain energy from where they're situated. Electrons can move between varying distances, emitting energy if they move closer to the nucleus. When this occurs, a photon is created. Planck's equation allows its frequency to be calculated. Simply rearrange h to yield a wave frequency, radiation from the electrons jumping. In fact, this is where light comes from. Colors correspond to the radiation. These frequencies encompass visible light, red being a low F and violet the highest. Outside of this range are waves you can't see. As you move towards the right, they have more energy. If instead electrons want to move away, they must absorb energy to reverse this display. The energy released by any given jump is the energy absorbed to restore its position. My next verse is indescribably important. It strengthens the competent concept of Planck's constant. The distances away an electron can be from the nucleus are limited. What does that mean? There's a finite number of jump distances, so energy amounts possible are limited. So no infinite division of energy. So no way this could be analyzed classically.
My God, I could never dream of discovering something like this. Let me in! Let me in! I recognize what the other minds have done for science now. I recognize that my work was meant to be built off of. I was never the father of all science. Just let me go home.
Have you learned what you needed to learn?
I believe so. Yes, sir.
And have you learned how to be less of a prick?
Well, I wouldn't phrase it like that. I find that quite offensive, actually. Just because you teach me valuable personality
Oh,
traits does
shut
not
up.
mean you get to insult me.
Alakazam!
The three laws: waves, electrostatics, fluids, circuits, thermodynamics, modern physics. Yep, I think I'm ready for the AP test now. Oh, fuck.